have a look at the chain rule. When we're taking the chain rule with derivatives, basically what's going to happen is we're going to kind of pretend that what's inside the parentheses is our variable, as if it was x to some power. So if you look over here, we're going to go ahead and we're going to take the number down front, multiply it by anything in front, subtract 1 from the exponent, and then we take the inside part and we get the derivative of that. Okay, but I think this one is easiest if you just see the process. So let's go through some examples. Okay, and now if I want to find f prime of x of this first one here, we're going to take that negative 3 is going to stay out front. We're going to take the other 3 and bring it down front because we're going to be multiplying the 4x minus 8 stays in parentheses, and then we subtract 1 from the exponent, so we have 2. Now remember, the last part that we do is we take the derivative of the inside part, which if I look at the derivative of 4x minus 8, that would just be 4. And then one more step here, we got to simplify. We got negative 3 times 3, which is negative 9. And I'm also going to multiply it by 4 here so that I can write negative 36 times 4x minus 8 to the second power. And now we've done the chain rule on this problem. Okay, let's go on to the next one. So on to the next one, we're going to have f prime of x again. So we're going to do the same process. Now there's only a 1 out front. There's no number written here. So we're just going to bring the 4 down. Then we're going to have 5x squared plus 2x. We're not going to touch that yet. We're going to subtract 1 from the exponent. And now we're going to take the derivative of the inside, which is just going to be 10x plus 2. And we're going to multiply it at the end. Now you could leave it like that, but I think it works out better if we distribute the 4 to these two numbers. And so what we're going to leave it as is then 4 times 10x. And really important thing to do here is put this in parentheses because really we're multiplying both of these numbers by 4, and that's all multiplied by this. 40x plus 8, and that's going to give me, I still have this 5x squared plus 2x to the third power. So now this one is done. Okay, let's look at a couple different situations here. Notice here, I actually have an option of doing the quotient rule on this problem, but I'm not going to do that because it's a little bit easier if I rewrite it. So first I'm going to rewrite it, and then I'm going to take the derivative. So this one, I'm going to have negative 4, and if I just take that whole denominator and I rewrite it, let's fix that 2. If I rewrite it here, I got 3x squared plus 4 to the negative 1. Now I can do the chain rule, and this is not so bad. So I actually think doing the chain rule here is easier than the quotient rule. So I bring the negative 1 down, times 4 is going to give me a positive 4. I got 3x plus 4. Now I'm going to go ahead and subtract 1 here is going to leave me with negative 2. And then the derivative of the inside, there's the chain rule part, is just going to be 6x. So last step here is to take that 6x and multiply it by 4. So I'm going to go ahead and do that. That is going to give me 24x times 3x squared plus 4 to the negative 2. Now you can leave your answer just like that, or you could write this as a positive 2, but it would now be in the denominator and still in parentheses squared. Okay, let's do another one here. Notice we have square root. Well, square root, let's go ahead and rewrite this before we take the derivative. That's just 2x squared plus 7x to the 1/2. So if I want to do this as a chain rule, well, it works fine with a fraction too. So I'm just going to go ahead and I'll say, bring that 1/2 down front. 2x squared plus 7x to the negative 1/2 here. And then I'm going to take the derivative of the inside part, which is going to be 4x plus 7. And now I have it, but I could simplify this a little bit. Like I feel like this one could be better to write as a fraction. So let's go ahead and do that. So what we're going to do is we're going to take this and we're going to put it back down into the denominator now because it's a negative 1/2. And we're actually going to have that 4x plus 7 sit in the top. And then we're going to have 2. And instead of writing to the 1/2, we're going to just go ahead and rewrite it as a square root. and we're going to leave our answer just like this. Now notice either one of these answers is correct, but in this case, if I needed to input a value for x, it's going to be a little easier for me to envision what that actual value is going to be equal to. So that's why I rewrite it like this, and keep in mind that the 1/2, because it's negative, it goes down in the denominator, whereas here, well, it's effectively in the numerator, but there's no fraction, and that's why it's positive to start. Obviously, after we take the derivative, it becomes negative. Okay, let's look at a couple special cases here of this is still the chain rule, but now we have some special cases of derivative where we're using trig and then e to the x. Okay, so let's start with this one. Well, I know that the derivative of sine is just cosine, and now I'm not going to, just like before, I'm not going to touch anything on the inside, and then I'm going to take the derivative of what's inside the parentheses. So that's going to leave me with negative 12x squared, and I like to just write this at the beginning to keep everything clear. It's negative 12x squared times cosine of negative 4x cubed. And now you're done with this one. Okay, last one here. Now, this is not, normally e to the x, right, would not change. E to the x, the derivative is just e to the x. It's the only time that happens. But here, we're going to have to think about what's the derivative inside the parentheses here. So I'm going to have 2e to the 4x squared, so that's not going to change, even though that is actually my derivative now. But then here I'm going to have the derivative of this, which is just 8x. And so I'm going to have 2 times 8x, which is going to give me 16x e to the 4x squared. And now this one is done as well.